A very happy morning, students. Today, let's talk about motion. Motion. What is motion? The change of position of an object with reference to time is known as motion. There are two types of motion: uniform motion and non uniform motion. Uniform motion. When a body covers equal distances in equal intervals of time, then the body is said to be in uniform motion. Non uniform motion. When a body covers unequal distances in equal intervals of time, then the body is said to be in non uniform motion. Now let's discuss the two most important terms of motion: distance and displacement. Distance is the length of the actual path covered by the object, while displacement is the shortest distance covered by any object in a specific direction. Distance includes only magnitude, while displacement includes magnitude with direction. Let's have a look on an example.
Hello friends, today let's talk about distance and displacement. In this case, a man standing at point A travels through this bumpy road to reach point B. So, the distance covered by this man would be the actual length of this path AB. But this is not the displacement. Displacement is the shortest distance covered in a specified direction. So, the displacement of this man would be the line joining point A and B. This was the basic difference between distance and displacement. Thank you.
Let's also have a brief look on the another two most important terms: speed and velocity. Speed is an indication of how fast an object is moving, while velocity is the rate of which an object changes its position in a specific direction. Speed is a scalar quantity. Standard unit of speed is meter per second. Velocity is a vector quantity. Let's have a look on the formulas followed by example.
Hello friends, let us talk about speed. What is speed? Speed is an indication of how fast an object is moving. Speed is a scalar quantity which includes only magnitude. Let us consider this case in which a car travels from point A to point B, which covers a distance of 100 meters in 10 seconds. Formula to calculate speed: speed equals to distance upon time. Let us put these values in this formula in order to get the speed of this car. Speed equals to 100 meters upon 10 seconds, which eventually get us to 10 meters per second. So, we'll say that the speed of this car traveling from point A to point B is 10 meters per second. Thank you. Today, let's talk about velocity. What is velocity? Velocity is the rate of change of position of an object with reference to time. In this case, a car displaces from point A to point B, which covers a distance of 200 meters in 20 seconds. Formula to calculate velocity is displacement upon time. In order to calculate the velocity of this car, we need to put the values of displacement and time. In this case, velocity equals to 200 meters upon 20 seconds, which eventually gives us 20 meters per second towards north. Thank you.
Acceleration. Change in the speed of velocity of an object per unit time is known as acceleration. Formula to calculate acceleration is change in velocity upon time. The SI unit of acceleration is meter per second square. There are two types of acceleration: uniform acceleration and non-uniform acceleration. Let's see an example.
Today, let's talk about acceleration. What is acceleration? Acceleration is the rate of change of velocity of an object with reference to time. Let us consider this case in which a car standing at point A covers a distance of point B, in which its initial velocity is 0 meter per second and final velocity is 40 meter per second. Formula to calculate acceleration, which is v minus u upon t. In this case, final velocity is 40 meter per second, initial velocity is 0 meter per second, time taken to reach point B is 20 seconds. So, acceleration of this car will be v minus u upon t, which is 40 minus 0 upon 20, which eventually gives us 2 meter per second square. Thank you.
Circular motion. The motion of an object along a circular path around a fixed point is known as circular motion. Movement of any object around this circle will be termed as circular motion. In circular motion, the speed of a moving object remains the same, but the velocity changes due to change in its direction of motion. Let's see an example.
Hi friends, today let's talk about circular motion. What is circular motion? The motion of an object along a circular path around a fixed point is known as circular motion. Let us consider this boy who covers a distance of 62.8 meters in 10 seconds. The speed of the boy remains constant, but the velocity changes due to change in direction. Formula to calculate circular motion is 2 pi r upon t. The circular motion in this case is 6.28 meter per second. Thank you.
Equations of motion. There are three equations of motion. First, v equals to u plus at. Second, s equals to ut plus half at square. Third, v square equals to 2as plus u square. Let's derive these equations.
Today, let's talk about equations of motions. there are three equations of motions. First, V equals to U plus AT. Second, S equals to UT plus half AT square. Third, V square equals to U square plus 2AS, where V stands for final velocity, U stands for initial velocity, A stands for acceleration, T stands for time taken, and S stands for distance. Thank you. Let's derive the first equation of motion. In this case, we'll take the graph of a uniformly accelerated car. The car initially starts from here and ends here. So the initial velocity of the car will be OK. Final velocity of the car will be BC. BC can also be written as BD plus DC. So we'll write V equals to BD plus DC. DC can also be written as OA, which again can be written as U. So V equals to BD plus U. On solving, V minus U will become BD. Acceleration is change in velocity upon time. So A equals to BD upon AD. AD can also be written as OA, which again can be written as U. So A will be BD upon T. On solving, AT will be equals to BD. BD here can be written as V minus U. So AT will be BD, or AT will be V minus U. On solving, V equals to U plus AT. This is how the first equation of motion is derived. Thank you. Hi, let's derive the second equation of motion. In order to derive the second equation of motion, we need to calculate the area of this whole portion. We'll take this portion in as two parts. First, this part as rectangle and this part as triangle. Distance can also be written as S. So we'll take S equals to L into B plus half into base into height. L into B can also be written as U into T, as this is the length and this is the breadth, plus half into T into V minus U. S, base is T and height is V minus U. S will be equals to UT plus half into T into AT, which will give us S equals to UT plus half AT square. This is how the second equation of motion is derived. Thank you. Hi friends, let's derive the third equation of motion. In order to calculate the third equation of motion, we need to consider this graph as a trapezium. The area of trapezium is half into P1 plus P2 into height. Distance will be half into OA plus BC into height. OA will be P1, BC will be P2, and time will be this height. So distance will be half into U plus V into height. According to the first equation of motion, we'll solve the value of T and put in this equation. Then we'll get 2AS equals to V square minus U square. On further solving this equation, we'll get V square equals to 2AS plus U square. That's how the third equation of motion is derived. Thank you. So, my name is Karthikar and I'm a student of Prelude Public School, Agra. Hope you like my video. Please like and share my video and subscribe my YouTube channel. See you soon. Thank you.